So I'm Cameron Robertson. I'm a founder and collaborator on this project called Kong. We'll get to what that is in a moment. But basically my talk today is trying to get folks to understand why I think crypto is broken and why hardware is one of the big solutions that I believe is important for it. So looking at the space of the last few years, there's been a lot of excitement, there's been a ton of speculation, but fundamentally the question becomes, where are the users? There's a few million people showing up, people registering on exchanges, but when it comes down to actually using dApps and actually signing up and creating accounts and sending tokens, we're kind of far away from the goal of where we need to be. And my biggest reason for that is holding your own crypto is really dangerous. The UX of crypto basically says, warning, you're gonna lose these keys. You set up a new wallet on a phone, it gives you this cryptic seed phrase. Everyday people out there don't really understand if they lose this, they lose their money. And so the experience for a person right out the gate who's not technical getting into something like crypto is really, really terrifying. So basically, this brings up the question of how has this shaped crypto? And I think it's shaped crypto in several ways. Number one, the primary place that most people out in the world interact with cryptocurrencies when they get excited by it is through exchanges. And frequently, they end up holding and leaving their crypto on those exchanges. And we sort of know all of the historical precedents of why that's risky. Of course, these are a bunch of exchanges where people lost huge amounts of money. So the other way that this has primarily shaped crypto is that people don't actually use crypto to buy real things. And when they do, you look silly because, you know, whatever it was, Bitcoin, Ethereum mooned after that, and you should have held on to it rather than spend it. And also in terms of like technological development, there's still a lot of pressure, not about like, let's drastically change the UX of what crypto looks like, but let's focus on TPS. Let's focus on making everything faster. We need to compete with Visa today. And my contention is, what we have today is actually working fairly well, and we can do a lot of incredible things on it. And since I first did this talk, like DeFi has exploded, and you can actually do all these amazing things on the existing networks as performant as they are today. So yes, we need the performance, but the overall focus on it has really sent us off the wrong direction. And my big worry for this is that we've shifted into the early adopter phase of crypto. We're past the innovators, and we're coming up to the chasm. And the chasm is, in sort of like innovation theory, this thing that we have to jump across before all of a sudden crypto is mainstream and people are using it everywhere. And what we do today drastically shapes what it's gonna look like when we cross the chasm. Is it gonna be that exchanges are effectively just the new banks and everything is centralized and crypto is mediated for everyday users? Or is there some way that everyone can have their own keys, they can have the sense of self-sovereignty? And so we put that question forth and we said, well, what if crypto acted more like cash? Now this may seem anachronistic. It's like, why would we use this old-fashioned thing for something that's entirely about digital online spending? Like the Bitcoin paper basically referenced spending electronic currency online. It didn't talk about physical. But cash has a huge number of benefits. Effectively, billions of people around the world know how to use cash since childhood. There's no direct transaction cost for the person actually spending it. There are, in fact, costs to handling cash, but that's a different issue. Transactions are instantly final. So we don't have to worry about network congestion, network times. We don't have to worry about random gas costs jumping and stuff because of those things. You can use it to buy goods and services. So I can show up to most businesses in many parts of the world and still just spend cash to buy a bottle of water or to buy a meal. There's a lot of anonymity in cash. It's not perfectly anonymous, but it's built in. It's a built-in feature. We don't have to re-engineer it to get there. And lastly, people understand that if you destroy it, you lose it, it's gone. The value is gone. Versus if I uninstall a wallet app on my phone and I didn't back up my seed phrase, I might lose a whole bunch of money and I didn't realize it. Cash is still massive. Even for the US dollar, there's $1.7 trillion of cash in circulation. I was recently at a banknote conference, and the funny thing is, even though cash use is declining in first world countries, cash demand has gone up. So there's actually way more cash which is getting printed. And leaving aside a few places like Sweden, Norway, in general, over 50% of transactions under $25 globally are still done in physical cash. So in order to understand if we want to make crypto cash, we have to think a little bit more about what cash is and what it represents. Cash is not money. Cash is a subset of that. Cash is a part of the money supply. And one of the key aspects of that is trust. You have to have paper cash that you can trust in. So one of the previous experiments of making crypto cash is, let's just print a private key on a piece of paper. It works really well for me to hand crypto from myself to someone who trusts me, because then they can scan the private key and they can pull the crypto off, and then that paper is worthless. But for actually circulating around between people across multiple parties, that obviously doesn't work. The first person pulls off the private key and then it's worthless. The next stage of this is, well, what about hardware wallets? Hardware wallets are really cool. They allow you to safely protect the key material, but the problem is they're incredibly expensive and they require you to trust the firmware. So even if now I don't have to trust that like the person who handed me this hardware wallet has like done something bad to the unit, I have to trust that at another point in the supply chain somebody didn't do something to the firmware, because it's all malleable. Someone could have changed the software on it, and then there's a backdoor to get the key material out. And then lastly, there's this thing called Java card or smart card. Effectively, most credit cards that you have in your wallet have this platform running on them, or a similar platform. It's based off, the original one was based off of Java, and they're running these miniature little applets in kilobytes of memory. And people are saying, oh, this is a great new way for us to make physical crypto. But we did a lot of research on them, and we're not quite convinced that's the case, because unfortunately, a lot of these Java cards have massive vulnerabilities. They're based on this 20-plus-year-old platform, which is fairly closed, and they have these dangerous APIs like get private key out. And I'll talk a little bit about what we've envisioned as a solution. So basically what this boils down to is trust in physical crypto is trust that the key material is not leaked, and someone else who you've passed it to, a previous party, can't just steal the crypto off of it while you're holding the physical note. So what we've built is physical crypto cash, and we basically have what we call a house currency. It's a demo currency called Kong, and what Kong is physical crypto cash with really high security guarantees and low cost. So let's dive into what exactly crypto cash is. Well, the clear number one thing is it has a printed face value. Any user interacting with can see the face value, they can read it, and they can have a high confidence that it's loaded with that amount of face value. The second part is it's not a hardware wallet. In fact, this device here is really an ultra-secure key signer, but the tokens are actually escrowed in a smart contract. And what that smart contract does is it allows you to set up rules at which point you will actually release the tokens. And so one of the most important rules that we've established is a time lock. So from the moment at which we mint a Kong note, you actually have to wait 3 years before you can pull the token off. And some people would say, well, that's weird. Why can't I just pull the money off immediately? And the main reason is it's not a prepaid gift card. We want cash to circulate, and for it to circulate, you have to be able to lock something up and say, no, this is going to be in its physical format, and we chose 3 years. The 3-year number is based on actual currencies in the world, where depending on what kind of banknote it is and where it is in the world, it'll survive for between 2 and 15 years. And then lastly is a secure element chip. And I'll dive into a little bit more exactly what I mean by that. So what does this kind of crypto cash actually look like? Well, there's a huge amount of historical precedent for this, because a lot of money in developed economies 100 years ago worked in a pretty similar fashion. The only difference is, for these, you could actually go to the Federal Reserve in the US for $5, and you could get silver back out. So you could take a note and get the amount in silver back out. And crypto cash is kind of similar, except instead of getting a precious metal, you get the crypto that's backing it. So what is a secure element chip? Secure element chips are kind of a broad classification, and that's a little bit frustrating. But the reason why we feel that way is we need some very specific characteristics. So as I mentioned, there are these Java card chips. Sometimes they're called secure elements, but they're highly programmable. There's a very small subset of those chips where their functions are fixed in hardware from the factory. By that I mean you can't write general code that will run on them. The only thing that you can get those chips to do is you can say, hey, give me a key pair and let me sign stuff using that key pair. And then the chip will not let you actually pull the private key out of it. So it's a very, very simple functionality, very small footprint. And because the software isn't malleable, it doesn't mean that you have these supply chain attacks where it should be loaded with the correct private key generation software, but it's been loaded with a different copy of it. So it limits the footprint there. But the big challenge for us is that all of these chips are based on the NIST-backed standard for ECDSA P256, as opposed to what we use in Ethereum and Bitcoin and most of crypto, which is K1. And so all that means is you can think about it as a compatibility difference, that one of them chose like the PC version and what we need is the Mac version. But effectively, the great thing about Ethereum is we can bridge that via smart contract. So what we do with Kong is fairly straightforward. We have a chip which generates the private key, the secure element. That private key never leaves the chip. And then we have a smart contract which is capable of understanding the P256 signatures and saying, yes, you are the holder of this note, I've seen it, and after 3 years, because I can see what the current block hash is and that you've signed it, you're able to claim the tokens out of the smart contract. Broadly, what we think this is, although we've made it for crypto cash to feel like money, is an entirely new construct that could be used in all sorts of crypto projects, and we're calling it a silo or a silicon lock contract. And basically what that means is that you can imagine tying physical or digital representations of assets to the physical thing. So you can do that for identity, you could do that for art. You could have art with these chips embedded in them or attached to them, and all of a sudden you're never able to separate the physical and the digital version if you don't want to. The nice thing about the smart contract is you can set up all sorts of different kinds of rules. So one of the things that we're thinking about with money is central bank digital currencies. Maybe if the central bank wants to unlock the money, they can, but you as an individual user can't. And then another case is asset tracking. So if you want to be able to track stuff in a highly secure way on the blockchain without having to have any middlemen in between, just between the chip and the device, then we believe that silos are a great way to do that. This brings us to the next point of what we're really focused on, which is all this boils down to the chip, and now we've reduced trust down to the hardware and saying that the functions of the chips need to be a certain way. And the implication there means that if people have demand for this, and if they have demand for attaching things to the blockchain this way, we need to have open chips, because right now, while we have all these wonderful open software libraries down to a really low level, we do not have that case for silicon. So here's an example that I love. It's from a Samsung chip from 2011. And effectively, at a microscopic level, the designers of the chip decided to like embed these designs in, which like they don't actually influence the functions of the chip, but it just means that we don't really know what's going on at a really low level in hardware. And the concerning thing about that is, even if you have a fantastically audited, formally verified crypto library and software, if you have even a small number of gates on a chip which have been modified, it can dump out its private key material. So all of a sudden, you can have really great crypto software, but if chips are broken or if they've been backdoor engineered, all bets are off. We're playing around with this in a project called ARX, arx.org. And the question is, can we quantify the trustworthiness of secure elements through crypto economic means? It's a fairly intriguing idea. There's a lot of problems with it. And we're trying to think of like mechanisms to do this. But the basic idea is, if the chips have guarantees that you can never get the private key out, but then someone does get the private key out and they can prove it, then you can show that on chain. And you can create certain incentives and disincentives for manufacturers where this is the case. So this whole topic, I believe, is really critical because it's not just in crypto, but it's all about the decentralized web. Because you look at what Google and Facebook and all these companies do today, and effectively they're key managers. They are managing, holding the keys that encrypt all of our data, our email, our photos, et cetera, et cetera. And I think the timing right now is perfect. Because what we saw in 2009 with Bitcoin was a breakdown in trust in the financial system, which allowed for this entirely new avenue of digital money to take root. And I think the same thing is happening as of last year, where trust is started to break down in these big companies like Google and Facebook, creating a massive opportunity for us to really build the decentralized web. But in the same way that crypto has shifted onto centralized exchanges, I'm hopeful that if we have new hardware, people can hold their own keys for the decentralized web as well. So quickly, just to wrap this back up, the point of this is we need usable self-sovereign crypto, and I believe Crypto Cash is one of the ways to achieve that, to onboard users to it. I believe ultimately they'll be using digital form, but giving them a physical, touchable money that they can handle first is important. To achieve this, we need open, secure chips. So we've reduced trust as far down as possible. So the only pieces of trust are the smart contracts, which are on chain and open and auditable, and the secure element chip, which its features are fixed in hardware. And then Kong is the first iteration of this. So after the talk, you can come take a look. I've got some Kong notes. We're handing them out as prizes to the winning teams. If you want to get started in learning a little bit more, we have a white paper which kind of explains how this works at a little lower level. We have an example of our escrow contract. So if you want to make a silo, it's really easy to get started, and that kind of links into our other contracts, like the one that processes the other elliptic curve. And then we have a community, a chat, which is on Keybase. You know, a small number of folks are interested in Kong Cash, but also asking about how they can build their own silos and work with technology. Also, if you're interested in making physical crypto, we're trying to help do that for other projects out there, not just Crypto Cash, but also for NFTs or identity tokens or other things. So, awesome, thanks a lot. And if you have any questions, just let me know.
What do you think would be the hardest to get people to start buying your things? Get people signed up and doing this? How long have you been doing this? What's the turnout? How are you seeing that?
Yeah, so we launched at DevCon last year, and we've been pretty quiet and heads down since then. The thing with physical crypto cash is it's a distribution problem. You have to get as much out there as possible. We've never really thought with Kong that's super viable, but we've been talking to a lot of other crypto projects. A lot of them, let's say in like stablecoins, are fairly interesting. The problem is then you get into this issue of, are you just making a really high-tech, expensive US dollar? And so fundamentally, there's kind of this balance of like, maybe stablecoins today are a little too immature before we get into new synthetic stablecoins that are not necessarily pinned to the US dollar, but have those kinds of characteristics. And there's a few of those projects, they're pretty cutting edge, but I don't think they're quite ready. So stablecoins is one of the interesting areas where we think, yes, if somebody wants to make 1 million or 10 million of these things, it's fairly interesting. The other one is as I mentioned, central bank digital currencies, which may seem sort of like out of place for a crypto project, but the interesting thing there is any central bank, when they print notes, they do it at a mass scale. And our hope is anybody doing this at scale means that we can push for an open chip, which is usable for the whole space. So one scale project means that we justify manufacturing a chip for all these.
Central bank, where I can guarantee you, and I tell you from because I talked to them about it, they're not doing retail.
So they are.
Not in Europe. All they're going to do in the back end?
Not in Europe, no, but they are in Africa and South America.
Yeah.
And those projects are launched, and so it's, there are hopes that it doesn't need to be the euro, but as long as one central bank somewhere in the world is interested in this, then. And the other thing is you can also use the technology for anti-counterfeiting, but honestly, like, I think those techniques that they already have are so sophisticated that adding a chip is not necessarily something they want to do. So.
And you will go over there, hey, use this here's the money. How are you trying to sell this?
So for central banks, it's not about Kong, it's about the technology.
Yeah.
And so for them, they have this challenge of central bank-backed digital currencies are easy for anybody who's a technology native to understand, but for older people who've used cash their entire lives, they have no clue about it. And you can have this transition phase where you can actually hand out central bank digital currencies in a physical form.
Is it correct to say sort of the chip holds the cryptocurrency and the note is just to convince the people that the chip is an authentic chip?
In effect, yes. Yeah. So again, the key part is the smart contract holds it, but if you lose the chip, you don't have access to the smart contract. But yes, so you could reduce all of this down to a single chip and you don't need the rest of the note. You could do whatever format you want. We stayed away from smart cards because they feel too much like credit cards, and the spending behavior around smart cards and credit cards is way different than cash, so we wanted something that felt like that. But I say effectively because you could have smart contract scenarios where, say, the physical version of this gets destroyed, and if nobody's claimed it in 20 years because you can't know if this got destroyed, then there's another party who has a first claim on it, like a central bank or some other entity. We don't like that for Kong specifically because we don't want any case where it feels like you might not be able to get your money with the physical thing, but you can imagine you can set up whatever rules you want in the smart contract for ultimately accessing the crypto asset.
Well, yeah, I was wondering, I mean, if you manage to crush the chip somehow, but the rest of the note stays pristine, so you could tell that it was authentic, could you redeem it anyway?
You could, well, only if there's a backdoor to the contract that let you ultimately do that. But if the chip gets destroyed, then you can't redeem it. Something I didn't demo in this, so this is actually NFC enabled, so I can use my smartphone myself, and I can directly challenge the chip to present a signature so that I can authenticate it. And so, for instance, if I was worried about a high value note, let's say this wasn't 20 Kong, but it was 20 pounds or $20, I can scan it, I can see the signature, I can verify against the public key and say, great, this is working. If I scan it and it doesn't work, maybe I won't accept it. Awesome. All right, well, thanks a lot. I'll be around the conference for the rest of the afternoon, and yeah, thanks for taking a look.